Welcome to this lesson on circles, angles, and arcs. The vocabulary for this lesson can be found in the attached document on the wiki page. We're going to start by talking about circles. And remember that a circle is the set of all points in a plane that are a given distance from a point called the center. In this circle, I have a center C, and the circle is formed by all the points that are the same distance from C. The radius is a segment that goes from the center of the circle to the circle itself. So we describe the radius as a segment whose endpoints are the center and a point on the circle. And this would be its endpoint. A chord, unlike a radius, actually is a segment with both endpoints on the circle. And a diameter is a special chord. It's a chord whose endpoints are on the circle, but it also happens to pass through the center. In working with circles, we are commonly interested in the angles that are formed at the center of the circle. A central angle is an angle whose vertex is at the center of a circle. So in this circle here, I have the point C, which is the center, and I have an angle that is formed by two radii. We usually measure these just as we would measure any other angle, and we call them a central angle. So essentially, a central angle is just a special angle whose vertex happens to be the center of a circle. If we added all the central angles in a circle, we would find that the sum of the central angles of a circle is always 360 degrees. That's probably why you've heard the expression that the sum of a circle is 360. Or you may hear someone use the expression that if you've turned in a circle, you've done a 360. We're next going to talk about arcs. And arcs are just a special part of the circle. It's kind of like a piece of the circumference. So the arc of a circle is a portion of the circumference. And arcs are measured by their corresponding central angle. It's very important that you distinguish between the difference in the measure of an arc and the length of an arc. They are two different quantities. So as I mentioned, our arcs are measured by their corresponding central angle. So in circle B, this central angle, if this angle were 110 degrees, so I would say that the measure of angle CBA equaled 110 degrees. Then I would also say that the measure of arc CA equals 110. An arc CA would be the portion of the circle that goes from point C to point A. Notice that when I name an arc, I write the letters and I put an arced line above it. A semicircle is a special arc, and a semicircle, of course, has a measure that is exactly 180. So a semicircle measures exactly 180. There are two different types of arcs. There are major arcs and there are minor arcs. A minor arc is always the shortest distance between 2 points, and we name it using just 2 points. So if I were to say arc CA, that means the shortest distance from C to A. If I want a major arc, that is always going to be the longer root of an arc. It will be greater than 180 degrees. And we use 3 points to name it. And the reason we do that is we have to distinguish, if I start at point C, which path do I take to get to point A? So to do the major arc, I would travel from C around the circle, passing through D, and on to A. So I use 3 points to name it, and again I put a curved line over the name so that I can indicate that that is actually an arc. It does not matter which points on the circle you use to name a major arc as long as you have the beginning and end points and any other point. So if I happen to have another point on this circle, such as point E, this very same arc could also be named arc CEA. They would be two names for the same arc. In order to determine the measure of an arc, as we said, the measure of the arc equals the central angle. So if it's a minor arc, I simply have to calculate that central angle. If it's a major arc, I take 360 degrees, which would be the total number of degrees in a circle, and I subtract the minor arc. So in this particular case, if I have a minor arc of 110, so I would say that the measure of this central angle, the measure of this arc CA equals the central angle. In this example, it would measure 110 degrees. Therefore, if I wanted to find the measure of the major arc CDA, I would say that it is 360 minus 110, or 250. A thing to keep in mind about arcs is always think of the minor arc as the shortest route and the major arc as the longest route. That's how we determine the measures of arcs. Finding the length is a different process. While measures are always relevant to their angle, a length of an arc is an actual distance. It's something that we can measure in feet or inches or miles. So we're going to calculate the length of an arc. Suppose in this circle B, I know that BA, which is a radius, is 9 feet. And please add feet here. And I also know that the measure of angle CBA, the CBA here, is 120. Find the length of arc CA. Since I've used only 2 letters to name it, I know I'm talking about the smaller arc, and the minor arc rather, and I have to have a little curve over there. You'll have to add that in because it's not possible in Microsoft Word. So to find the circumference of a circle, I use the formula C equals 2 pi r, and in this case we've said that the radius BA is 9. So in order to calculate the circumference, I would say that C equals 2 times pi times 9, which equals 18 pi, and if you calculate that out, you'll get 56.5 feet. That's the circumference of my entire circle. In order to find the length of just the arc, I'm going to use a proportion. So remember that a proportion is always a part over a whole. And I'm going to rely again on my central angles to figure out that proportion. I'm going to set it up as I have 120 degrees, that's the measure of my arc, over the measure of the whole circle, 360. That's going to equal the length of my arc over the length of the entire circle, which was 56.5 feet. So this here is the whole circumference. Of the circle. Once I've set up my proportion, I can use cross multiplication to solve. So I would do 120 over 360 equals L over 56.5, cross multiply, just like you'd solve any other proportion, and you'll find that 360L will equal 120 times 56.5. In order to solve for L, I would divide both sides by 360. And I would get a final answer that L will equal 18.8. And remember, we have units when we're looking for length. So it would be feet, since I measured my radius in feet.